Welcome to 2.3 Subsets of Planes. So if you need to review the vocabulary word of a plane, remember that is one of our undefined terms, but also what you really need to remember is that a plane goes infinitely in two directions, both length and width, but it has no thickness. So our first postulate is called the Plane Separation Postulate, and just like the Line Separation Postulate, where we have a point divides two lines into two rays, we have a line dividing a plane into three disjointed sets, the line and the two half planes. So here's a visual. The best that we can do with drawing a plane is that it looks like this. Right, just you have to remember that these lines are just so that you could know it's a flat surface. The line AB separates plane K into half plane 1 and half plane 2. Okay, so definition of a half plane is a subset of a plane consisting of all points on a given side of a line on the plane. So if points P and Q are the same half plane, then so is the segment that joins them. An edge of a half plane is the line that separates the plane into the two half planes. Okay, the line is not part of either half plane, just as the point was not part of either ray on the half line when we talked about the line separation postulate. So there's a lot of similarities here. Opposite half planes are the two half planes that are separated by the line on the plane. So if points P and R are on opposite half planes, then the segment must intersect the edge or the line that's separating the half planes. So I'm going to show you a picture. This is plane M, and line F now separates plane M into half plane 1 and half plane 2. I have points P and Q, and just like in our definition of half plane, it said if points P and Q are in the same half plane, then so is the segment that joins them. Okay, so you have to imagine this. I think I did draw a segment, I just drew it in the wrong spot here in my animations. And then if we have points P and R, then they are in opposite half planes. Then if you imagine a segment PR, it's going to intersect line F. So there's segment PQ. I do not have a segment PR, but you just have to imagine if I drew the line, this line segment there, that it would intersect line F. Another subset of a plane is an angle. Okay, an angle is the union of two distinct rays with a common endpoint. Okay, so normally we've been talking about a point in between, for betweenness, that is also an angle. It's called a straight angle, and we're going to get into that later, but right now let's talk about two rays that are not collinear. Okay, they make an angle, and here you thought an angle was just something you measured with a protractor, but it's actually the union of two rays with a common endpoint. Now the sides of the angle are the two rays that form the angle. A common student error is when they think of the interior of the angle as part of the angle, and it's not. Okay, the interior is separate from the rays as far as set notation goes. The vertex is the common endpoint, or the origin of the two rays. So here we have a plane. We have ray that goes in one direction with the going toward the A direction, another angle going in the C direction. The vertex is B. Okay, so this angle, we would name it ABC. The vertex letter always goes in the middle when you are naming an angle. That is also a common student error. They will just label the letters in any particular order, but the order of the letters matters. CBA is the same angle as ABC, but B has to be the vertex, and it is the middle letter. The interior of an angle is the intersection of the two half planes, which determined by the side of the angle and each containing the other side. Okay, it doesn't include the vertex at all. So here's our picture of that. Okay, here I have a half plane that's divided by line DE. And here I have another half plane that is divided, the plane P, by the line CB. Now you see D is a common point that these two lines have, so we can actually talk about their rays, DC and DE. So the interior would be what the the intersection of those two half planes, which would be that funny pink part in the middle where they overlap. That's what they have in common. That's the intersection. So the pink part is the interior of the angle. The angle itself is CDE or EDC. And as you would expect, the exterior of the angle is the complement of the union of the angle and its interior. So it's everything except the angle and the interior of the angle. So if we go back to this picture, it's the blue section is the complement. Okay, so let's do some practice. Let's do half plane 1 intersect line F. Where do they intersect? If you said they don't, you are correct. The null set. Remember, the plane separation postulate says that they are 3 distinct separate sets. Now let's talk about half plane 1 union half plane 2, and then what's the complement of that. So what is everything except half plane 1 and half plane 2? Because if we union those together, we are going to be left with one thing, and that would be the line F. Okay, it's the only thing not included on plane M. Now, E is in the interior of what angle? Okay, the interior of what angle? A, B, and F. So if you look at B being the vertex of the angle, and those lines go on an infinitely long, right? E would be in the interior of the angle. Remember, it can't be part of the ray of the angle. That is the angle, not the interior. Ray BC is a side of what angles? So look for BC, and it's a side of a few angles here. Again, we'll talk about straight angles later, where that would be CBA, would be a straight angle. We're not talking about that quite yet, so I didn't want to get ahead of don't get ahead of yourself here. Talk about angles. So we've got CBG and FBC. Four angles with the vertex of D. Go ahead and write those for yourself before you continue on. Make sure you hit pause. Did you get them right? Now name points on the exterior of BCD, the exterior. You okay with that? Remember, you definitely have to come with a question, so if you're not okay, this would be your question. Okay, for your WISC summary, it's going to be a little different than we've done before. I want you to find an example of the line separation postulate, and I want you to find an example of the plane separation postulate in quote-unquote real life, daily life, and I want you to explain why it meets the line separation postulate explanation and the plane separation postulate. So you need to have 2 examples, 1 of each. And because these answers are going to vary, everyone's going to come up with different stuff. I'm not going to be emailing you a reply. I have my own examples, but they're not necessarily going to be your examples. And just because I email you mine, you still won't know if you're correct or not. So we're just going to discuss this further in class. And so I will see you then.